All right, here are solutions for perfect problem 7 from Math 243. We got a random sample of 80, it's N, dog owners. And out of those 80, 68, our calculator will call that X. But that also tells us that P hat is equal to 68 over 80, which is 0.85. Anyways, 85% let their dog sleep inside. I know that 75% of all dog owners, so this is a population proportion here, I'd like to use P for it. I want to use P for something else, so I'll use P naught, 0.75. Of all dog owners let their dog sleep inside, can I conclude that Oregonians' dog sleep behavior is different? Different is going to be a key word here. It doesn't say there's a higher proportion or a smaller proportion. It says different than normal with 99% certainty. Sure. 99% certainty tells us that alpha is equal to 0.01. 1 minus 0.99, which is 0.01. Okay, state the null and alternative hypotheses. Null hypothesis, alternative hypothesis. They're both always going to compare P, the population proportion of all Oregonian dog owners, number we don't know, with P naught, 0.75 in this case. So going to be always comparing P and P naught. The null hypothesis will always say that those two are equal. Our alternative hypothesis will, to figure out what symbol goes in here, you have to read the question. That's this different thing that I made a big deal about. Because it says different, we put does not equals here. If it said is higher than, we'd put greater than. If it said is lower than, we'd put less than. But it doesn't. It says different, we put does not equals. That tells us that we have a two-tailed test. State the null and alternative hypotheses. There they are. State and justify the shape, center, and spread of this distribution. Shape better be approximately normal. It is. Shape is approximately normal because that's the only thing we can deal with in this class. But really the reason why is because the central limit theorem tells us that if n times p, well, okay, n times p times 1 minus p is greater than or equal to 10, then our shape is approximately normal. Problem, we don't know what p is. Solution, the logic of hypothesis testing is you start out by assuming the null hypothesis is correct. So we start out by assuming that P equals P naught. So whenever I want to know P down here, I'm just going to use P naught in its place. So if I do 80, I guess I could check that, 80 times P naught is 0.75, in other words 3/4, times 1 minus that is 1/4. That's what, 240 over 16? I think that's right. I should check it on a calculator because I have one right here. But 8 times 3 is 24, so 80 times 3 is 240. 4 times 4 is 16. 240 over 16, that's greater than or equal to 10 because 160 over 16 is 10. So I'm good here. N times P naught times 1 minus P naught, sure enough, is greater than or equal to 10. Shape is approximately normal. Center, I'd like to use P. However, I don't know P. I assume that P equals P naught under my null hypothesis, so the center of my distribution will be 0.75. Spread. The way I come up with the spread is I have a formula for it. It used to be P times 1 minus P over N, square root of all that. Again, I don't know P. Again, I use P naught in its place. So P naught is 0.75. P is 1 minus P naught is 0.25, and N is 80. So this number, whatever that is my spread. All right, draw some pictures. Draw a picture for the classical method. Draw a picture for the p-value method. If we're doing the classical method, I start out by drawing my distribution. Give myself a little bit more room. I'm going to make the shape of this distribution approximately normal. I'm just going to try to. And the center is at 0.75 out here. That has a z-score of 0. And what I want to do is set up rejection regions. This is a two-tailed test, so I'm going to have a rejection region over here and a rejection region over here. the total area of those rejection regions should be equal to alpha. Alpha is 0.01. Make that a little bit easier to see. If the total area is 0.01, then this is 0.005, and this is 0.005. I want to figure out the z-score that corresponds with having 0.005 above it and the one for 0.005 below it. Fortunately, my calculator has a function that does that for me. It's the inverse norm function. So if you go under distributions and down to inverse norm always wants the area below. So if I put in 0.005, comma 0, comma 1, it's going to give me this negative number out here, negative 2.576. And if I had put in 0.99501, it would have given me 2.576. Those are what are called my critical values. What I want to do is find my test statistic and see if it falls within one of the rejection regions. See if it's higher than 2.576 or lower than negative 2.576. The way I do that is my calculator will calculate that for me. If you go to tests and then one prop z-test, you can just give it all the information we have. P naught, we have that's written down as 0.75. X, that's 68. N, that's 80. Our alternative hypothesis is that P does not equal P naught. And then you can either go calculate or draw. Either way, it'll give you all the information you need. It'll tell you that Z is 2.06. It's over here somewhere. So my sample, P hat, which was 0.85 up here, corresponded with the test score of 2. Let's call it 1. 2.1 is not in the rejection region. It's lower than 2.576. So I would say because my test statistic, which was 2.1, is not in the rejection region, there is not sufficient evidence to reject the null hypothesis. Sure, that's a J. Let's try that again. Reject the null hypothesis. I am not saying that the null hypothesis is true. I am not saying that P equals P naught, that the proportion of Oregonians that allow their dog to sleep inside is the same as the overall average. I'm not saying that. I'm just saying there's not enough evidence to conclude that that's not the case, which is what this says down here. You can get to that same conclusion by using the p-value method. Same idea, start by drawing a picture. Sure. Put the center, 0.75, that has a test statistic of 0. You don't have to set up rejection regions for the p-value method, which is kind of nice. You just go straight into this one prop z-test like we did before, put in the exact same information, and it'll tell you everything you need. You can do either calculate or draw. Maybe I'll do draw just to mix it up a little bit. If you do draw, it'll draw a little picture for you. Your job is to copy that picture over here. So note the picture has a shaded region on both sides. That's because this is a two-tailed test. And it tells me that my test statistic is 2.1. 2.0656. What is this number right here? 2.1. And the p-value, kind of the total area of here and here, is 0.0389. So what? Okay, what you do when you use the p-value method is you compare this area with alpha. Alpha was just 0.01. Because my p-value is greater than alpha, there is not sufficient evidence. So maybe I'll put in like ... And then over here I could put in ... So for this reason, we draw the exact same conclusion. Anyways, there's the classical method and the p-value method for doing proportion hypothesis testing.